Welcome to the video solution of your selected question from the Mathematics the Easy Way DVD. If you have not yet seen the introduction video on the DVD, please do so now, as it outlines how the Easy Way series will help students to be successful in their CXC exam. While the Easy Way video solutions will help to cement the understanding of certain special questions, the solution books are still absolutely necessary as they cover all the various types of questions that are set in CXC exams.
And now question 3 of this CXC CSEC June 2013 General Paper 2 exam video solution. Now part A of question 3 is a sets question, and it tells us of 30 students in a survey who take photographs. And some of the students use cameras to take photographs while others use mobile phones. Now, the universal set here has the 30 students in the survey who take photographs, and the subsets of the universal set are set C, the students who use cameras to take photographs, and M represent the subset of students who use mobile phones to take photographs. Now, we are told that 20 students use mobile phones, 4x students use camera only, x students use both mobile phones and cameras to take photographs, and 2 students use neither cameras nor phones to take photographs. And the first part wants us to complete a Venn diagram that represents this information, and this is it. The number of students in the universal set is 30, and so this rectangle, which represents universal set, has 30 students in total. And then the two subsets of the universal set are C, representing the set of camera users, and M, representing the set of mobile phone users. And we are told that 20 students use mobile phones, and so the total in the subset M would be equal to 20. So here we would have the mobile phone only, students who use mobile phones only, and here we would have students who use both mobile phones and cameras to take the photographs. And so the total in the mobile phone users would be equal to 20, as information stated here. And then we're also told that 2 students use neither. So it means that outside of these 2 subsets, there will be 2 students. And so we can show that here. So these are the 2 students who use neither camera nor cell phones. And then we're also told that X use both. And therefore we have to show that value of X in the intersection here. And this is it. X is the number of students that use both. And we're also told that 4x use camera only. This subset here represents the students who would use cameras only, and so 4x must be placed here. Since the total number of students in the mobile phone subset is 20, and we have x in the intersection here, it means that the remainder 20 minus x would be the ones who use mobile phones only. And so to complete the Venn diagram, we must place 20 minus x right here, such that the total in this subset is 20. And that's it. Our Venn diagram is now completed with the 4 regions completed. Now part 2 wants us to write an expression for the total number of students in the survey. So the total number of students in the survey is represented by the sum of the students in the 4 regions of this universal set. And so the expression for the total would be this. The 4x from here, 4x plus 20 minus x plus 2. And that's what we have here. 4x plus 20 minus x plus 2. This expression represents the total number of students in the survey. And we can reduce this by adding the terms in x and adding the 20 to the 2 right here. And so that reduces to 4x plus 22, because this x would eliminate this minus x, and so we're left with 4x, and then 20 plus 2 is 22. And so this expression representing the total number of students in the survey reduces to 4x plus 22. Part 3 now wants us to calculate the number of students who use camera only. Now the students who use camera only are the students in this region right here, and that's 4x. So basically we want to calculate the value of 4x. That's the number of students who use camera only. So let's show that. That's what we want. We're trying to find 4x. And we know that the total number of students in the survey is equal to 30, and therefore this expression here, which represents the total number of students in the survey, is equal to 30, and therefore we can use that information to calculate what 4x is. And to calculate 4x from here, we simply subtract the 22, and when we do that, we end up with 4x being equal to 30 minus 22. 30 minus 22 is equal to 8, and so 4x is equal to 8, and so the number of students who use camera only, which is 4x, is equal to 8. And that's the answer for part 3 of question 3a. Let's move down now to question 3b. Now question 3b gives us these two right-angled triangles, ABC, this larger triangle ABC, that's a right angle right here, and this smaller triangle right here, ADE, and also that's a right angle right here. So there are two right angled triangles, and we are given these dimensions. This length AC is 10 meters, AB across here is 8 meters, and BD right here is 3.2 meters. And so because we have the total length here is 8 meters and this piece is 3.2 meters, we can calculate the length of AD, which would be AB minus DB right here. And so to do that calculation, we show it here, it's 8 meters minus 3.2 meters, that's 4.8 meters. And so AD is 4.8 meters. 8 minus 3.2 equals 4.8. And so we can show that on the diagram. This length is 4.8 meters. So that's all information we have so far. Now, part 1 wants us to calculate the length of BC. That's this height here. And if we focus on this larger triangle, it's a right angle triangle, and therefore we can apply Pythagoras' theorem. But what we can use is the fact that we have a Pythagorean triple. Now, a Pythagorean triple is a ratio of sides of a right angle triangle. The sides of a right angle triangle forms what we call a Pythagorean triple. And there are some standard Pythagorean triple that we have. And the first one is the 3-4-5 Pythagorean triple. We refer to it as a 3-4-5 triangle. So triangles whose sides are in the ratio 3 to 4 to 5 are called Pythagorean 3-4-5 triangles. And this triangle, we see that this side is 8 and this hypotenuse is 10. So if we look at this ratio 3-4-5 and multiply it by 2, we see that this will become 8 and this will become 10, right? And that is multiplying the 3-4-5 by 2. And this is it. It will become 6, 8, 10. We already have two of those sides in this right angle triangle, the 10 and the 8. And therefore the third side, if we look at the Pythagorean triple 3-4-5 multiplied by 2, the third side here, which is BC, would be 6. And therefore it would be a 6, 8, 10 triangle. So this approach uses our ability to recognize that this is a 3-4-5 triangle multiplied by 2. That would be a 6, 8, 10 triangle. And so the length of BC using this recognition method would be equal to 6 meters, because this then would be a 6, 8, 10 triangle. And so we can show BC equals 6 meters on the diagram right here. And so BC is equal to 6 meters. But if we could not recognize the Pythagorean triple 3-4-5 multiplied by 2, then we could proceed in the normal way and use Pythagoras' theorem for a right angle triangle. And this is it. We could say that the hypotenuse squared, that's AC squared, is equal to the sum of the square of the other two sides of the right angle triangle. And so AC squared is equal to BC squared plus AB squared. That's what we have here. BC squared plus AB squared, that's these two sides, the sum of the squares of these two sides, AB and BC, is equal to the square of the hypotenuse, focusing on this large triangle ABC. And if we transpose this to make BC the subject, then we would end up with this. We subtract the AB squared first, and then we take the square root of both sides, and we are left with BC equals the square root of AC squared, that's the hypotenuse, minus AB squared. And if we plug the numbers there, we would end up with BC being equal to the square root of 10 squared minus 8 squared. 10 squared is 100. 8 squared is 64. 100 minus 64 is 36. The square root of 36 is 6. And so BC is 6 meters using Pythagoras' theorem. And so the answer here is that BC is equal to 6 meters. Okay, so let's proceed now to part 2. Now part 2 is asking us to explain why triangle ABC, that's this larger triangle here, is similar to triangle ADE. Triangle ADE right here. So question is, why is this larger triangle ABC similar to this smaller triangle ADE? Now, as a general rule, two triangles are similar when three angles in one triangle is the same as the three angles in the other triangle. Two triangles are similar if all the angles in one triangle is equal to all the angles in the second triangle. The length of the sides might be different, but once the three angles are the same in the two triangles, then those two triangles are similar triangles. So what we can do to prove that these two triangles are similar is show that the three angles in each of the two triangles are equal. And let's proceed with that method. So firstly, we can call this angle here theta and show that on the diagram. That's angle BAC. We are calling that angle right here theta. And that is it. Now, because this is a straight line and this is 90 degrees and this is 90 degrees, then it means that these two lines are parallel. And also now AC is a straight line. So with AC being a straight line and these two lines being parallel, it means that we are forming corresponding angles here and here. When parallel lines cross a straight line, they form corresponding angles. So this angle and this angle are corresponding angles, and corresponding angles are equal. So we can use that information to show that this angle is equal to this angle right here. So that's it. Corresponding angles are equal. And so angle AED, that's this angle right here, is equal to angle ACB, that's this angle right here. So these two angles are equal, and we can call those two angles alpha. We can call those angles alpha and show alpha there and alpha here. So these two angles are equal. So now we can show that the three angles are equal in the two triangles, which would what would make them similar. So if we examine triangle ADE now, that's this one, ADE, we see that the three angles are theta, alpha, and 90 degrees. These are the three angles in this smaller triangle, theta, alpha, and 90 degrees. And if we remove the information here, so we can focus on the larger triangle now, which is this larger triangle ABC now, we see that these three angles there also are theta, alpha, and 90 degrees. And that's it. The three angles in triangle ABC are also theta, alpha, and 90 degrees. And based on this rule for similar triangles, once the three angles are the same in both triangles, it means that the triangles are similar, and we have shown that. And so we can put back that information and write our solution line. The two triangles are similar because we have shown that the three angles in one is equal to the three angles in the other. And so the two triangles are similar. Let's move down now to part 3. Now part 3 wants us to calculate the length of DE. That's the length of this side right here. And based on the information we have that this triangle is similar to this larger triangle, we can use a rule that says the ratio of corresponding sides of similar triangles are equal. But in this case, because we have right angle triangles, it is easy to prove that rule. And I'll take the opportunity now to prove that rule. This is it. The ratio of corresponding sides of similar triangles are equal. So let me explain what I mean by this. And as I said, we have right angle triangles and we can use our trig ratios to prove it. So let's use the tangent trig ratio to prove it in those two similar triangles, triangle ADE and triangle ABC. Let's go through the steps. Now, tan theta in this smaller triangle is equal to opposite divided by adjacent. So tan theta would be equal to DE divided by AD. So let's show that. That's it. In this small triangle, tan theta is opposite divided by adjacent. That's DE divided by AD. And if we look now at the larger triangle, where this is the angle theta, this becomes the opposite side, this becomes the adjacent side in this larger triangle. And so tan theta in this larger triangle now is equal to BC divided by AB. That's it. BC divided by AB. And if we move this tangent trig ratio, we see that the rule falls out. The ratio of corresponding sides are equal. And if we put back this information so we can see the two triangles, you see the ratio of corresponding sides being equal. So it's this vertical side divided by this horizontal side in the small triangle is equal to this vertical side divided by this horizontal side in this large triangle. The ratio of corresponding sides are equal. This over this and the small triangle is equal to this over this in the large triangle. And that's what we can use to calculate the length of DE. All we need to do now is plug the values in for the sides that we know, and we are actually trying to find the length of DE. So if we substitute the values that we know, BC is 6. So we have substituted 6 for BC right here. AB is 8. We have replaced AB here with 8. And then AD is 4.8. AD is 4.8. So this AD, replace it with 4.8. And so we are left with DE to calculate. And so to calculate DE, we simply multiply both sides by 4.8. And when we do that calculation, we end up with DE equals to 6 divided by 8 multiplied by 4.8. And when we do that calculation, we end up with 3.6. And so the length of DE is 3.6 meters. And that's the answer for part 3 of question 3b. And that's the end of question 3. So we'll do question 4 in the next video. See you then.
You have just seen the video solution for a special CXC question, but this is only one of the many different ways that these questions are written. All mathematical principles can only be fully understood by solving many questions, and so I always tell my students, more maths equals better maths, and if they study hard, they will pass easily. All the various types of CXC questions are covered in the Easy Way Mathematics Solution book, and you need to practice every single one of them. Other books in the series are the Easy Way Multiple Choice Specimen book, the Easy Way Unit 1 Cape Mathematics Solution book, and the Easy Way Account Solution book. Please feel free to contact me with your comments and queries at any time.